Very warm good morning to my dear children. Today we are present here with the chapter D and F block elements. D and F block elements, students, very important block in the periodic table. We have completed, my dear children, the S block elements, P block elements, and today we will start the D and F block elements. You know, students, there are total 4 blocks in the periodic table. S block elements present at the leftmost part of the periodic table. P block elements are present in the most right part of the periodic table, and D block elements present in the middle part of the periodic table, and F block elements present below of the periodic table. Now, my students, I am going to start the D block elements. Now, children, periodic table. Just you are seeing here periodic table of the elements. In the left portion, that is the S block elements, and in the right portion, P block elements, and group 13 to group 18. 13 to 18 groups belongs to group P block elements, group 1 and group 2 S block elements, group 3 to group 12, my dear children, present in the D block, and lanthanide series and actinide series, 4F block and 5F block elements present here in the periodic table. So, my dear children, just you have seen that is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. These 10 elements are present in the 3D series. That is the first transition series contain scandium to zinc. Second transition series, that is 4D series, started from yttrium, having the atomic number 39 and end to the cadmium atomic number 48. And my dear children, the third transition series, that is 5D series, starts from lanthanum 57 atomic number and mercury 80, that is the end element of the 5D series, and 6D series, incomplete series, my dear children. So students, for your knowledge, I want to share here, that is we have to study the 3D series, that is scandium to zinc, and scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. These 10 elements name you have to know. This is the first thing. First thing in this chapter, you have to know the position of the D block elements. My answer is, it is in the middle part of the periodic table. Okay. Next, the name of the 3D series you have to learn. Scandium to zinc. Next, students, how many series in the transition elements? That is 3D series, 4D series, 5D series, and 6D series. Which series elements we have to know? My dear children, we have to know about the 3D series elements. 3D series elements. Next, students, very important things. The D block of the periodic table contains the elements of the group 3 to 12. So, how many groups are included in the D block elements in 3D series? Your answer is, ma'am, group 3 to group 12. How many groups are included? 10 groups. How many groups? 10 groups, in which the D orbitals are progressively filled in each of the 4 long periods. 4 long periods means 4th periods, 5th periods, 6th periods, and 7th periods. My dear children, from the 4th period, the D block element started, and the first D block element is scandium, having the atomic number 21, and its configuration is 3D1, the first electron goes to the third 3d orbital in case of scandium. So first we have to know the 3 to 12 group includes in the D block. Next things, the elements constituting the F blocks are those in which the 4f and 5f orbitals are progressively filled. So D orbitals are progressively filled, D block elements. 4f and 5f orbitals are progressively filled, they are known as the A block elements. There are mainly three series of the transition metals. 3d series, scandium to zinc, 4d series, yttrium to cadmium, 5d series, lanthanum to mercury, omitting cerium to lutetium. The fourth 6d series, which begins with actinium, is still incomplete. The two series of the inner transition metals, 4f and 5f, are known as lanthanoids and actinoids respectively. Lanthanoids and actinoids. The very interesting things, students, 4f and 5f blocks elements are known as, yes, your answer is right, my dear students. 4f blocks elements are known as lanthanoid series and 5f block elements are known as the actinoid series. Very important things. And which is the D block elements? Your answer is the electrons when progressively filled in the d orbital, then the elements are known as D block elements. And F block elements means when electrons enters progressively to the F block, then these elements are known as the 4f or 5f block elements. How many series? 3d, 4d, 5d and 6d series. Which series is incomplete? Answer, my dear students, children, is 6d series is the incomplete series. Just you have seen here scandium 21. What is the atomic number of scandium? 21. Titanium 22. Vanadium 23. Chromium 24. Manganese 25. Iron 26. Cobalt 27. Nickel 28. Copper 29. Zinc 30. 3b, 4b, 5b, 6b, 7b group, 8b group include the element that is iron, cobalt, nickel, and group 1 and group 2 divided in the subgroups A and B, and group 1b include the copper and group 2b include the element zinc. Yttrium 39, cadmium 48, lanthanum 57, mercury 80. And actinium 89. Actinium 89. And you have seen in the A block elements 4A blocks, that is C, it is completed to Lu. Next 5F, that is thorium 90, it completed to Lr. So my dear children, 4A blocks lanthanoid series, because after lanthanum 57, cerium 58, it is the starting element, first element of 4A block, and actinium 89 and thorium 90. So the 5A block first element is thorium, it is after actinium. That's why it is known as the actinoid series. It is known as the actinoid series. Now students, I am coming to the definition of the transition elements. A transition element is defined as the one which has incompletely filled d orbital in its ground state or in any of its the oxidation state or in any of the excited state. So the element which has the incompletely filled d orbital, just you underline the word incompletely, students. How many electrons can hold in d orbitals? You know, students, there are 5 suborbitals in the d orbitals: dxy, dyz, dzx, dx square y square and dz square. And you know, students, in an orbital there are 2 electrons. So there are 5 suborbitals in d orbital. That's why d orbital has the capacity to hold 10 electrons. So when there are less than 10 electrons, then it is incompletely filled d orbitals. And my dear children, I am telling you, transition element has the incompletely filled d orbital. But one exceptional case here, just you have seen zinc, atomic number 30, cadmium 48, and mercury, that is 80. These three elements, the last element of 3D series, that is zinc, last element of 4D series, that is cadmium 48, and mercury, the last element of 5D series, 80 atomic numbers. And do you know, these elements have the completely filled d orbital, that is d10 configuration, in their ground state as well as in their common oxidation state, and hence are not regarded as transition elements. Students, frequently the question is coming, why zinc is not considered as the transition elements? Then what you have to write? Zinc atomic number is 30. After that you have to write its configuration is argon 3d10 4s2. It has the completely filled d orbital. That's why it is not considered as the transition elements. So what is transition elements? Incompletely filled d orbitals element is known as the transition elements. Which elements are not considered as the transition elements? Zinc, cadmium, and mercury. Next, which groups are included in the transition elements? Answer is 3 to 12. Third group to 12th group are included in the transition elements. Transition elements are metals, non-metals, or metalloids. Answer is all elements are metals. All elements are metals. Where the transition elements belongs in the periodic table? It is placed in the middle of the periodic table. It is after S block elements and before the P block elements. And the properties of the D block elements are transitionals of the S and P block elements. That's why these elements are known as the transition elements. So this question answers now, students, we have got. Now position in the periodic table, just I had to discuss here. The D blocks occupies the large middle section, flanked by S and P blocks in the periodic table. Second, electronic configuration of the D block elements n-1d 1 to 10 ns 1 to 2. This is very, very important. Half and completely filled set of orbitals are relatively more stable. Students, can you tell me, any students, why half-filled orbitals are more stable? Why full-filled orbitals are more stable? Tell me. Yes, half-filled, that is D5 and D10 configuration, is more stable because their symmetrical arrangement of the electrons and the exchange of energies in the orbitals are two reasons for the extra stability of the half-filled and full-filled orbital, my dear children. Students, you see here, a consequence of this factor is reflected in the electronic configuration of chromium and copper in the 3D series. Do you know what is the electronic configuration of chromium? I think many students know. Chromium is argon 3d5 4s1 and copper is argon 3d10 4s1 in the 3D series. Consider the case of chromium, for example, which has 3d5 4s1 instead of 3d4 4s2 instead of 3d4 4s2 because 3d5 orbitals is more stable than 3d4. 3d5, it is the half-filled d orbital, my dear children. So here what we have to learn, the general electronic configuration of D block, that is n-1 d1 to 10 ns 1 to 2. Now students, up to this, next day we will discuss the physical properties, but today up to the electronic configuration of the D block elements. Thank you students. Next day we will start the physical properties, that is melting points, boiling points, atomic radii, ionic radii, electron gain enthalpy, ionization enthalpies, different types, characteristics of the D block elements. Next day we will study. Thank you. Be safe. Stay healthy.